Hi, my name is Isabel Martínez Gallego. I'm from First A and I will explain the sign binary multiplier, the Booth's algorithm. The Booth's algorithm is a tool used to multiply or divide two numbers. One of them is a multiplier, another a multiplicand. One of them is positive, another is negative. These on the screen are the math bases to this algorithm. And they use some formulas and some variables in order to define the performance of this algorithm. Now we're going to see the architecture we're going to use to store the information. The performance phases are first of all the initialization, that is not going to be repeated but it's not as necessary to be known it. And the ones that are going to be repeated are these on these loop phases. The first of all is to read these two positions in order to determine what is going to do the process after that. Depending on the order and if they are the same or different, we're going to do something or something else. The second one is to increment one in one the counter. The third one is to shift everything to the right. And the fourth is to check the counter in order to know if we have reached the end of the process or not. First of all, we're going to define an example. We're going to use 14 by minus 5 in order to get minus 70. We put everything initialize and we check the first step, that is to check those both positions that will determine what we are going to do. We increment the counter, we move everything to the right. One position in register 4 is lost, but it's okay, it's just lost. We have to store all the information in register 3 in not a binary way. We check the counter and we see that we have to repeat it again because it's not at the same. This time we have to do nothing because both the bits are the same. We increment the counter, we move everything to the right, storing in the position required the information we need, and we check again the counter. We copy everything up and we check again. This time we have to add it. We get 10. We store all the information need. The new one is in blue and the done before or just that one is not changed is in black. And we move everything to the right. After incrementing the counter, we check again and we do it once more. We check, we have to subtract this time. We complete the information, the new information. We increment the counter, move everything to the right, storing the information needed. We check that we have to do the loop once more. This time we have to do nothing because they were the same. We increment the counter, move everything to the right, and the result is gonna be there. It's gonna be in pink and it's gonna be the same as the. And that's my summary. Forgive my mistakes and thanks for watching it.